Solutions Architect with AWS. And today we're going to be delving into the very exciting world of big data, looking specifically at how that relates to the startup community. Just a little bit of housekeeping first up. Obviously, we run these webinars for you guys, and we really encourage you to ask questions throughout the webinar, and we'll be able to answer those for you. And we also ask at the end of the session if you wouldn't mind filling in the feedback form, and that's very useful to us, obviously, for future sessions to make sure that we're giving you as much benefit from these sessions as we possibly can. So just a quick intro on AWS and the startup community. Obviously, we have a great affinity with startups because we really understand the journey that you guys are on in terms of having an idea, moving that into an MVP, scaling that up, and then obviously eventually becoming very profitable. And what we see with the startups that we are involved in is that obviously once you have your product, you focus on that for a long time, how to ship it, how to develop it faster, etc., etc. And then when you have that in place, you then move on to the next question, which is, okay, how do we market this? How do we scale our operation to take advantage of this? And then you start asking yourself a lot of analytics types of questions. So what are consumers doing? Why do they do it? How can we market to those consumers more effectively? And how can we optimize our systems? And this is obviously where analytics and big data plays a big part. And if you look at a big customer of ours, Airbnb, obviously a very popular startup in the US. For those of you not familiar, they're essentially a marketplace that brings together people looking for a place to stay and people who can provide a place to stay. And Airbnb is the marketplace to link those people together. And they've had enormous growth over the last few years. They're now up to 10 million guests, over 500,000 properties listed on their site, and obviously that's all been done on AWS, and they've had massive growth on us. Very large investment, but also very large valuation, larger in fact than some of their competitors in the market, some of their more traditional competitors. And there's a great tweet actually from their founder where he says that that Marriott wants to add 30,000 rooms this year, and he says, well, we'll be adding that in the next couple of weeks. So huge growth. Obviously, they're very focused on their customers. And there's a great quote from one of their software engineers where he basically says that we're constantly looking into possible ways to improve our product and our user experience. And this often involves lots of analytics behind the scenes. And that's a great lead into today's session. We're really going to focus on analytics and how you do that effectively. A couple of other startups that you are probably well aware of, lots of local names in there, which is fantastic. Obviously Druva from India, Zalora and Wego, local to the Singapore market, 9gag in Hong Kong. All these guys run some sort of analysis on us, and we'll be looking at some of these guys as we go through. So the agenda today is to have a little overview of the big data market as we see it, some of the technologies that make up the big data space, and then we'll delve into each of those technologies in a little bit more depth, but always tie that back to a customer experience so you can see how they've been actually using the technology for their advantage. So let's talk about the big data market. Has obviously become very complicated, lots of vendors, lots of different open source products, lots of technologies, and I really wanted to boil it down for you into its constituent components. So firstly, obviously there is Hadoop, which a lot of people feel is synonymous with big data. And for those of you who've not come across Hadoop, it's basically a framework for analyzing very large amounts of data across commodity components. So you get commodity machines and you spread that workload across lots of machines to be able to crunch through the processing that you need to. The other technology that we see a lot of is MPP databases. And MPP stands for Massively Parallel Processing, and this is a breed of database which is all about analytics across large data sets. So different from a transactional database in that all it does is just focus on giving you great performance for SQL-based queries across large data sets. Obviously, we need to touch on the NoSQL technology as well, and this is another technology that was really born out of some frustration with traditional SQL databases, especially for web-scale types of transactions where developers really found themselves needing very high transactional either reads and writes, and simply weren't getting that from a traditional relational database. And so that's how the NoSQL movement was born, and we'll have a bit of a look into that as well. And then overlying the top of this, we're now seeing a real rise in customers wanting to do some kind of streaming analytics on their data. And so we see customers who, yes, they might have data in that comes at them in batches, but also we have a lot of customers where the data is actually streaming, whether it's coming off sensors or coming out of games or off a click streaming, etc. And they want to be able to capture that information and also analyze it potentially in near real time as well. Now, each of these technologies is available in all sorts of different forms. There's lots of different vendors and lots of different open source options. Amazon actually has managed services in each of these spaces. So if I overlay them, the AWS services across the top, you can see with Hadoop we've got EMR, which is Elastic MapReduce. For the MPP databases we have Redshift. For NoSQL we have DynamoDB, and then the streaming services called Kinesis, and we'll touch on these as we go through as well. So one of the first questions that customers often ask us is, a lot of these technologies are designed for large data sets, but what should I use and when should I use it? So when should I use Hadoop versus an MPP database or a traditional database? When's kind of the right time to use them? And so often we find it very useful to look at a couple of factors. The first is, what's the size of the data set that you have, and also how structured is that data set? So if you look in the bottom left-hand corner, you can see that you've got your traditional relational database, which can deal with relatively small sets of data, and that data needs to be highly structured. So it is a database. You do need to create the data model beforehand, and when you load data in, it has to conform to that structure. And then as you move up a little bit to the up and to the right, you'll see that the NoSQL databases are much more flexible in terms of the data that they can support. So we talk a lot about schemaless databases with NoSQL, and that just gives developers a lot more freedom and flexibility to put stuff into that database rather than having it conform to that very rigid structure if it doesn't really need it. And then you move up to the top right where you get into the Hadoop type workloads, and here really all bets are off in terms of the structure. So one of the great things about Hadoop is you can throw pretty much anything at it and it will be able to deal with it. So it's fantastic for unstructured data, semi-structured data, etc. And then where the MPP databases fit in is in that top left-hand corner there. So yes, they deal with very large data sets, but the data does need to be very structured. So it is a relational database, so it does need that schema to be defined and the data to be loaded up. And so often that's a very good place to start when you're trying to determine what type of technology to use, is what is my data? How structured is the data? If it's highly structured, then it could be that potentially an MPP database might be the right choice. If the data is very unstructured, perhaps Hadoop is going to be a better option. And don't think of this as an either-or as well, because we have a lot of customers now where it's very common for them to actually use the technologies in conjunction with each other. So often we'll see potentially a NoSQL database will be the capture mechanism for data. It'll then be run through a Hadoop cluster to clean it up, maybe do some transformations, give it some structure, and then it might actually then get pushed into an MPP database for final analysis. So we certainly see these technologies as very complementary rather than a one-size-fits-all type of approach. So as we go through, I just want to touch on these technologies and look at the different facets. So we've mentioned structure, but I also want to talk about latency as well. So what kind of performance are you expecting if you ask a question to one of these technologies? What kind of response time will I expect when I actually fire off a query? And then there's interfaces as well. So what kind of technologies do I use to actually ask a question of these technologies? And so we'll look at that as we go through. And again, that's really a way just to determine which workload should fit with which technology. So let's start off having a bit of a look at Hadoop. And the background to Hadoop is actually quite interesting. In 2004, Google released a paper called MapReduce, which was really all about taking up a particular problem and splitting it up over a large number of machines to try and solve that problem more quickly. And then in 2006, there was a guy called Doug Cutting who was working for Yahoo at the time, who took the MapReduce concepts and married it with some of the work that he was doing, and then that became what we now know as Hadoop. And one of the interesting things about the name Hadoop was he was searching for a name to call it, and he actually ended up using the name of his son's stuffed elephant as the name of the technology. So Hadoop was his son's toy elephant, and that gave us the name, and then also obviously the familiar icon. So if you're looking at Hadoop and the Hadoop ecosystem and you're wondering why there are so many elephants in it, that's why. So taking a very high-level simplistic view of Hadoop, essentially what it is a cluster of machines or nodes that all work together to solve a problem. So you create your cluster with a certain number of nodes in it, and then you have your input file, and then you have your functions or your algorithm. What do you actually want to do with the data? The input file gets split up, gets pushed into the cluster along with your function, and then the output is returned to you. Now, there's a couple of facets of Hadoop that have made it extremely popular across all industries. The first one is that it's extremely flexible. So because the functions that you're using are very rich languages like Java and Python and Ruby, etc., what you can actually do on your data is very rich indeed. So people love the flexibility that Hadoop gives them. It's also extremely scalable. So because you can add and remove nodes to a cluster, that allows you to make the cluster much bigger if you need to potentially work through a data set quicker. So a common pattern there is customers have a certain log file size potentially after a day's trading, but then every now and again, maybe on a holiday or the weekend, they suddenly have a much larger transaction volume, and they still want to get through the processing in the same amount of time, so they simply beef up the cluster and then just churn through it much more quickly. The other interesting facet about Hadoop clusters is that there's a couple of ways in which customers run them. So some customers will run them in a very permanent fashion. So they'll actually store the data within the cluster, and then they'll constantly be pushing queries into the cluster, asking questions of the data and getting result sets back. But the other way that customers run them is in a much more transient fashion. So instead of storing the data in the cluster, they'll actually push the data into the cluster when they need to do the processing on it. And then when the output comes out, then they'll actually shut the cluster down. And so the third point there is that you do have that option to use the clusters in a very transient way. And when you look at how we run this on AWS, this is a facet that actually fits very nicely, obviously, into the way that you consume resources within AWS. So because of the flexibility and the scalability of Hadoop, it's really taken off in pretty much every single vertical and every industry you can think of. And everybody's got a different use case for it. Obviously, within the retail space, using it for recommendations is very popular, as is analyzing transactions. In the telco space, it's analyzing call detail records. But because of this ability to pretty much take in any type of file, you do see it also being used for image processing, image recognition, all sorts of different use cases. The deployment options that you have for Hadoop are obviously you can run it on-premise, so you can run it yourself. There are many distributions out there that you can download, install them on your own machines and run. Or you can take that same distribution and install it on the cloud, so you could potentially run up some AWS virtual instances, which we call EC2. You can do that, and then you're then managing the cluster yourself on virtual infrastructure. Or the third option is you can actually go with a managed version on the cloud as well. So we have a managed Hadoop offering called Amazon Elastic MapReduce. And the advantage of using something like Elastic MapReduce is that we take a lot of the hardship of actually managing the cluster. We take that out of your to-do list and put it onto ours. So manageability is the main plus there, in that you just tell us how many nodes you want, what type of machine you want, and we'll then get all the machines up and running, install the right software, make sure they're all talking to each other, and then just present you with a running cluster. There's also the scalability aspect. So Hadoop loves to scale, and obviously when you're running that within the cloud, you've got the option to pretty much throw as many instances as you want at that. And so that scalability piece plays in really nicely into running that on the cloud. And then there's cost as well. So there's numerous ways to really use Amazon very effectively to run up very beefy clusters, but not pay a huge amount for them. We don't really have time to get into this here, but there is great use of the spot market within the Hadoop community, within EMR, that a lot of customers do. So if you're interested in that, please let us know and we can talk to you about the most effective way to run clusters cost effectively. So I wanted to give you a quick case study. One of our customers called Yelp. If you're not familiar with them, they basically run a recommendation site. And interestingly, they're not an e-commerce site themselves. They don't actually run any transactions on their site. But a lot of the things that they do and a lot of the analysis that they do is actually very similar to the types of processing and analysis that a lot of our e-commerce customers do. So they're a very popular site. They get a lot of monthly visitors. There's a lot of reviews on there, and that obviously generates a lot of logs. So they get roughly 400 to 500 gig of logs per day. But those logs are very, very important to them, because what they do is they use those logs to drive a lot of the functionality on their site. So for example, the classic autocomplete for the search box, where somebody will start typing in a restaurant name or a hotel, for example, and they will have a drop-down that will basically autocomplete based on what the site thinks they're looking for. There's also the ability to actually fix up spelling that customers make. So someone will just put in what they think is the spelling for a particular hotel or restaurant, and then they'll come back and say, did you actually mean this particular venue? And then there's obviously the classic people who looked at this venue also looked at these other ones as well. So I want to just have a look at that, the top left one there, where the site will actually ask you if you're looking for a particular property if you spell it wrong. And the way that that works is that what Yelp do is they take their search history and they load that into Amazon S3, which is our storage service. And the logs look a little bit like this. So this is obviously a slightly dumbed down version, but essentially it's got the actual text that the customer wrote into the search box, and then the property that they actually ended up clicking on. And so that sets up an association between the final selection, the actual correct spelling, and what people actually typed in. And so what Yelp want to do is they want to actually set up then the ability for the site to know if someone starts to type in something incorrectly, what they're probably looking for is the correct spelling on the right. And so what they do is they feed in these logs into an elastic MapReduce cluster. So they spin up quite a large one. It's a 200 node cluster, and that will essentially split that job up across all of the nodes, looking for those associations. That takes a couple of hours, and then they'll then push those results back into S3, and those results will probably end up in some kind of NoSQL database so that they can be picked up by the website extremely quickly when customers are on the site. But because the processing is now finished at the back end, they'll actually shut that cluster down. And so this plays into the transient nature of Hadoop that we were talking about before, where if you're using something like EMR, you're only paying for it when it's running. And so if you can run your job in a couple of hours, then you shut it down. You stop paying for it until the next day when you need it again. Another quick case study along the e-commerce lines, which is Etsy. Most people have heard of Etsy. It's an online marketplace specifically for vintage and craft type items. And they also are a big EMR user, and they use it to analyze all of their weblogs, and they use that for recommendations that they push back to the site. But what they do is very interesting, because they actually link all of their weblogs with their production database as well. So their production database has got the catalog in it, what things have been purchased, how much they've been purchased for, and so they link that data in EMR with all of the weblog data, and that gives them an extremely rich place to play and to do recommendations that they can push back to the customers. And there's a great quote here from Etsy where they basically said that EMR enables them to focus on developing the analysis stack without worrying about the underlying infrastructure. And I think this is a really key message, which is, what is the core nature of your business? The core nature of your business is probably not trying to stand up Hadoop clusters and get them to work. Your core business is actually developing your service and your product. And so that's why I like this quote so much, because basically it's exactly what we say to customers, which is, let us worry about the infrastructure and you guys do the interesting stuff on top of it. Now, there's a very rich ecosystem of products and services and libraries that sits on top of Hadoop. I won't go through this here, but obviously that's one of the other reasons that Hadoop has become very popular, is there's a lot of different, very specific add-ons that you can place on top of it to increase its applicability for certain workloads. But I wanted to mention a couple of trends in this space as well, because it's a very fast-moving space at the moment, and some of the trends identify exactly some of the issues that people have with Hadoop. One of them is that it's potentially quite hard to use. So, as I said, a lot of the functions that you write in, the languages are very rich, but they're also quite low level. So we're talking about Java and Python, etc. Now, that's not a very business user-friendly type of interface. And so there's been a big push to try and make Hadoop more business-friendly by layering SQL on top of it. And this is actually a very active space right now. And so you'll see, if you start to read any of the literature on Hadoop, you'll see that there's a lot of talk about different SQL layers on top of Hadoop. The other very key area of development with Hadoop right now is something called Spark. And the reason I mention this is because Hadoop is often talked about as a batch technology, that you push things into it. You don't wait around for the result because you know it's going to take a couple of hours to run, and so you come back when the batch is finished. And that's mainly due to the MapReduce framework underneath. And so there's a lot of work going on at the moment to replace that with a much faster in-memory type of framework, which is called Spark. And so again, you'll see a lot of that talked about as well. So coming back to our matrix here, so just to finish off with Hadoop, so the structure can be pretty much anything. The latency is generally minutes or hours to wait for the batch to finish. As I said, that is changing with the introduction of Spark, but a lot of people still use it very much as a batch engine. And the interfaces are, you're looking at kind of a programming interface. There are some SQL-like layers on top, and they're starting to become quite a rich tool set as well that you can use on top of Hadoop. So let's move on to MPP. So MPP stands for Massively Parallel Processing, and this is a breed of SQL databases that are designed purely for analytical workloads. And they were really born out of a frustration with traditional SQL technologies that as the data sets grew, people were finding it harder and harder to analyze the data in a timely fashion. And so the MPP databases were really designed to address the performance of those traditional technologies, also the scalability. So there came a point at which you couldn't throw any more hardware at the traditional SQL databases to make them actually perform any better, whereas with the MPP databases, they were designed with scalability in mind. Also, there's the ease of use factor as well. So as those traditional technologies started to struggle, a lot of customers would spend a lot of time and energy trying to make them perform. So they would be indexing them, they would be partitioning them, they would be doing all sorts of things, which is obviously expensive, and that made the cost of those technologies quite expensive. So one of the other facets that MPP was trying to address was the cost of doing analytics on SQL. So if you look at the architecture, most MPP databases have got this kind of structure. They differ slightly, but this is kind of the main thrust of it. They've got a leader node out the front, which kind of controls the whole show, and then you've got the compute nodes at the back end, and the compute nodes are the ones that are actually doing all the work. And so if you look at the compute node, it follows a shared nothing type of architecture where those nodes don't actually share anything with any other node. So they've got their own disk, their own memory, and their own CPUs. And that allows you to scale that layer out very widely because there's no contention for resources as you add more nodes. And so you can kind of add tens or hundreds of nodes together to get very large clusters. So very scalable. But the great thing about them is they run ANSI standard SQL. So it's pure SQL. It's not SQL-like or a strange dialect of SQL. It's pure SQL, which is fantastic. And what that means is that along with the high performance, you can also use a very broad set of tools that have been around for a long time. So a lot of business intelligence tools have been around for 30 years. You can plug them straight into the MPP databases and they'll work. Again, your deployment options for MPP databases, you can run them on premise, either as an appliance, or you can get software only. Again, you can run them on the cloud, so you could run up EC2 and install an MPP database on top of that. Or there is also a managed version on the cloud, which we call Amazon Redshift. And again, very similar to EMR, a lot of the benefits of Redshift are around the manageability of it. So instead of you having to install software, make sure all of the nodes are talking to each other, deal with failover, all that kind of thing, we'll manage that for you. Just tell us how big you want the cluster to be and we'll run it up for you. Again, scalability is a big factor too. So MPP databases, similar to Hadoop, they love to scale. So if you run them in the cloud, you've obviously got the ability to scale your databases up and down by adding more nodes or taking nodes away if you don't need them. And then again, also cost. So Amazon Redshift is extremely cost effective when you compare it to other MPP technologies. So I wanted to give you a quick case study of a customer using Redshift Foursquare is obviously, again, a very well-known startup. They have a location-based social app where you essentially check in at different places and in order for your friends to find you. Again, they similar to Airbnb, they've scaled up very quickly. So they've got 40 million users now and 4.5 billion check-ins, and that obviously adds up to multi-terabytes of log data. But again, that log data is very, very rich, and Foursquare need to sort through it because it's got a lot of fantastic information for them, but also for their customers. So the actual venues themselves, the places where people are checking in, obviously that information is very, very valuable. And so they run analysis such as, who's checking in, males and females, then by age. No surprise there that it's kind of the early 20s who are driving most of that. Although I have to say I was quite pleased to see that even though there's quite a heavy drop-off, there are some over 50s who are actually getting into the Foursquare action. So that was quite good news. And then obviously onto the actual venues themselves. So when do people go to a place? And as I said, you can imagine that this kind of information is crucial for these venues who are trying to obviously attract a certain type of clientele, and you can imagine you marry that information with potentially what was the weather like on that day, what sports were on TV, and the people that run those venues have then got a much better idea of who's coming and how those factors are affecting their business. So Foursquare are a heavy Amazon Redshift user. And basically their quote there was that it's enabled them to do much more agile analytics while also saving cost. And so the key benefit there is that because your queries run so much faster, you're able to run more of them and you're able to start to follow a train of thought. So you'll ask a question, the answer comes back, you drill in a bit further, etc., etc. If the query comes back in an hour, then it's unlikely that you're going to keep going with that train of thought because you've probably forgotten what the question was in the first place. Whereas if the answer's coming back quickly, then you can obviously be much more agile with that. Another interesting case study was Sling Media. And these guys, if you're not familiar with them, do place shifting in media streaming. So basically the ability to decide when and on what device you actually want to watch a certain program. And again, you can see the recurring theme here. These guys are collecting terabytes of event logs, but those event logs have got all sorts of really interesting information about the viewership. So how are people watching the shows, at what point do they stop watching them, but also what devices do they watch them on, and at what times, etc. And again, all that information is very interesting to Sling Media themselves, but also to some of Sling Media's customers as well. And here's an example of a customer who's actually using Hadoop and Redshift together. So they use Hadoop for the transformation of the data, so it comes in reasonably messy, if you like. They use Hadoop to give that a bit of structure, and then they put it into Redshift for analysis. The quote here from these guys, it's a bit of an American saying, but they said that using Redshift allowed them to turn on a dime, which basically means it allows them to be, again, similar to the previous example, very agile in the types of analysis that they do. So because they're not constrained by which columns have been indexed or anything like that, they can basically ask pretty much any question. And so if they suddenly decide that they need to do analysis in a certain area, they can just go and do it. They don't have to restructure all of their processing. So we've talked a bit about performance. I just wanted to show you this quickly. Obviously, when a database vendor shows you a slide telling you how fast their database is, you take it with a grain of salt. But this was actually run by one of our customers, and they wanted to see what the comparative performance was of a traditional SQL database, Hive running on Hadoop, and then also Redshift as well. So they had 2 billion rows that they loaded up, and the query was a relatively simple one. They just wanted to do an aggregation of the data by month, but obviously they're going to have to do a full table scan on that data set. So that took just over 2 hours in the traditional system. Took about 35 minutes in Hive and ran in 12 seconds in Redshift. Now this isn't meant to be in any way a dig at the traditional SQL databases. They're obviously a key part of our landscape. It's more a comment on the fact that this type of analysis they weren't really ever designed to do. And so that's why you see that discrepancy in performance, is because the MPP databases like Redshift are designed for that kind of query. So that's why you see such a massive discrepancy there. So to finish off on MPP, the structure of the data, as we said, it does need to be fully structured because it is a database, but the latency is seconds and minutes, so it is that kind of interactive speed. And the interfaces into the MPP databases, it's standard SQL, and then it's BI tools, so business intelligence tools that have been around for a long time. So a very nice, rich tool set for you to use to visualize and ask questions of the data set. So moving on to NoSQL, and again, not to bash the SQL traditional SQL databases too much, but again, the NoSQL movement was really born out of a frustration with SQL databases and their inability to scale when the transaction volumes became very high. So whereas the MPP databases were frustrated at the traditional SQL databases when the data volumes got too high, the NoSQL guys were all about transactional volume. And so they're really databases that are designed for web scale transactions, so many thousands of reads per second and many thousands of writes per second. And there were really two facets that they were trying to address in the traditional SQL world. One was performance, so that ability to actually get data in and out very quickly, but also flexibility. So the NoSQL movement kind of said, look, the traditional SQL databases, they've got a lot of things that we just don't need. So we don't need joins. We don't need relations. We can do away with all of that. We don't necessarily even need to adhere to a particular data model. We don't want to have to create our columns beforehand. We want to just be able to put into the database whatever we get. And so that flexibility was another key reason why the NoSQL movement took off. So if you look at a traditional relational table, you've obviously got your predefined columns there. What that might look like in a NoSQL database is that you would still have a key, the ID column, but then you'd have a big attributes column where basically you just put all the attributes in there, but you're not bound to that. So if you've got age and state information, you can put that in, but if suddenly you find out a bit more information about your user, potentially their gender and whether they're a smoker, you can put that in as well. If you don't have the information, then you don't put it in. And so for many applications, this is a fantastic flexibility that they have in order to be able to just take whatever data comes at them. So again, your deployment options with NoSQL, there's many out there that you can run on-premise, you can install yourself. Again, you can install them on virtual instances in the cloud. But also we have a managed cloud version as well that we call DynamoDB. Now, I am drawing a fairly broad brush here over the NoSQL databases. There are actually 3 or 4 different categories of NoSQL database. So the one that DynamoDB falls into is a key value store, where you do have that key on the left and then you have all your values. But there are other types of NoSQL, such as document stores, like Mongo, for example, or Graph NoSQL databases as well. So once again, one of the prime reasons that you might go with a managed service like DynamoDB is, again, just that manageability. So we will manage the infrastructure underneath it for you. And in fact, DynamoDB goes one step further than our other managed services, where you don't even need to tell us how many nodes you think you want. You simply tell us how many reads per second you want and how many writes per second you want, and then we'll actually go and provision the hardware to provide you with that performance. And so that really abstracts you again from having to even think about, well, how many instances or nodes do I need for this? You just work out what transactional volume you need, and we'll make it happen for you. It's a very, very scalable product, so you can really drive incredible scale from it. And again, very cost effective when you look at other options. So we've talked about the NoSQL guys were really initially all about performance. And so when you look at something like DynamoDB, this I think really kind of brings it home as to what we're talking about. So across the top, that blue line is your average number of requests that are coming in, and that can obviously vary very widely because it's a web service, so you're not quite sure how many people are going to be hitting it. But the latency line, which is that bottom green one, doesn't change at all, and that's what you want. You want that very consistent performance regardless of how many people are hitting the service. And that latency there, that average latency in milliseconds, we typically talk about single-digit milliseconds when we're talking about that kind of NoSQL response time. So here's an interesting case study in the ad tech space. So these guys, AdRoll, what they do is they have clients who want to advertise to certain demographics, and what they do is they basically provide the mechanism to bid in real time on the space that becomes available on websites for advertising. So what this looks like is that if you're a client of AdRoll, when a user comes to your site, you have a little pixel there that will fire off back to AdRoll and allows AdRoll to create a profile of you as a user. Now then, as you as a user then go surfing around the web, and then you hit a site that's got some banner advertising in it, what the people who own the website want to do is allow people to bid for the space on that site. So bid for the banner space on the site. So they'll actually send information out to a real-time bidding engine to say, a user's come to our site, do you want to bid for the space that's on this site for advertising? And so what then happens is the advertising agencies have to decide, do we want to bid for that space? And if we do, how much do we want to bid for it? And if we do win, what ad do we actually want to slot in there? And so if they do make that decision, then they'll obviously push that ad out. Now the interesting facet about that whole thing is that whole exchange has to take place between the time that the user clicks on the link and when that page is fully rendered. And so you've only got about 100 milliseconds to receive the information from the real-time bidding engine, make a decision, and then push your response back to the bidding engine. So you can see there's about 40 milliseconds of network, 20 milliseconds of kind of buffer, and then you've really got 40 milliseconds in which to do your thing, to actually process that information. And so that's why people like AdRoll use something like DynamoDB, where they know that they can get information out of that database very, very quickly. And you can imagine that because of the number of clients that they've got, the number of ads that they're bidding on at any one time is extremely high. So they do about 2 billion transactions a day. And so when you work that out at how many transactions per second they're doing, it's an enormous number. So they need a database that not only can they get in and out of very quickly, but that can scale if they've got hundreds of thousands of transactions all happening at once. The other great thing I love about the AdRoll guys is they talk about their use of Dynamo, and then they talk about how much it costs them to run it. And the way that they talk about that is that they actually compare it to the amount of money they spend on snacks for their developers. And so they were very happy that they could actually spend less on DynamoDB than they could on the snacks that they feed to their developers. So just finishing off on our matrix, so we've got NoSQL on the far right. So in terms of structure, the NoSQL guys deal with much messier data, so you can kind of have unstructured or semi-structured data. But the latency is sub-second, and the interfaces are pretty low level. So there's no real standard for NoSQL at the moment. So you do tend to end up kind of programming at an API type level. There are some of the NoSQL guys do have kind of SQL-like layers, but it still, you tend to kind of trend more towards the more low-level type of interfaces and languages. So hopefully that's given you some examples and also some kind of structure around how we think about what technology is right for a customer depending on the workload. And we think that it's usually pretty obvious when a customer talks about their workload as to which technology fits it. And as I said, often it can be a combination of two or three of these to actually meet the customer's requirements. Now, the other thing I wanted to touch on was streaming analytics as well. And so what we're finding is that our customers are often dealing with not only batch data, so data that's potentially coming at them once a day or once a night or even once an hour, but data that's actually constantly streaming towards them. And we see these use cases across the board. So we see it in gaming, so in-game analytics coming out of mobile devices. We're seeing it in sensor networks, so people who've got sensors embedded in the road or in traffic lights or telemetry from cars, etc. A lot of data coming off ad networks, so the real-time engines that we were talking about before, they actually produce a very, very large amount of data. We also see customers just using it for log centralization. So they just want to say, I've got a lot of logs being generated by different systems and I need something to capture them. I want to stream those logs to something that's actually going to hold those logs for me durably and safely and let me then do something with them. Obviously, clickstream analysis is another very, very interesting area for streaming data as well. Now again, there's lots of different ways that you can do this. There's lots of different mechanisms to capture data and then deal with it. But customers did ask us to step into this area because they were finding that managing that themselves, managing those instances and keeping all of those machines running and making sure they weren't losing anything was becoming quite onerous. So they asked us if we would actually produce a service that did that. And so we do like to listen to our customers, so we released a service last year called Amazon Kinesis. And the interesting thing about Kinesis is that we'd actually been struggling with that whole real-time thing ourselves. We'd actually built some infrastructure to deal with the real-time streaming of logs. So if you know AWS at all and you're familiar with CloudWatch, you can imagine that CloudWatch is trying to collate a lot of information that's streaming off a lot of infrastructure. And the ability to then actually pull that information in and then produce the real-time graphs that you see requires quite an interesting approach. And so we already had a lot of experience, obviously, in doing that, and so we then applied that to a service for customers, and that's what became Amazon Kinesis. So what you see there at the moment is that bit in the middle is what we call a Kinesis stream. And what you do is once you create the stream, you then have your data sources on the left and they push their messages into the stream, and you'll see there's 3 availability zones there. So every message that comes in, we write that to 3 availability zones, so 3 different data centers, if you like, 3 different physical locations. So that gives you the durability of the message. And then what we do is we'll hold each message for 24 hours, which then allows you to write your consuming applications at the back end to then pull that information out of the stream and then do something with it. And a lot of people look at that architecture and say, oh, that sounds very much like a message broker. Well, the interesting thing is, in some ways it is, but there's one key difference, and that is that with a message broker, often as soon as a message has been read by a worker, you want that message to be hidden from any other workers because you don't want that message to be processed twice. However, with Kinesis, the use case actually is that you do want every message to be seen by each application. And so if you look at the applications on the right-hand side, some of the examples that we've seen from customers already, if you look at application number 1, that might be simply reading every message in the stream and just writing it to a log. So that's its sole purpose, is just to keep an audit log of every message that's come through the stream. The second one might actually be trying to give us some kind of real-time dashboard. So pull out key metrics, some key KPIs from the stream, potentially put them into Dynamo, produce a dashboard so we can kind of see over the last 2 minutes how many people are browsing on the site, have we had any 404s, whatever it might be. There also might be alarms, for example, so read certain metrics that are coming off the stream, and if a particular value in the stream is out of bounds, then send an alert or an alarm to somebody. If you look at application 3 there, where we'll talk about sliding window analysis, this might be where you want to do slightly longer term analysis. So maybe it's what's happened today, this week, or maybe over the last 6 months, but you want that information to be constantly fed by the real-time information that's coming in. And then the application number 4 might be doing something even more interesting, which is potentially some kind of machine learning. So to help you to develop those apps, we've produced a number of connectors into some of the Amazon technologies. So if you're just going to be writing a log, you can write that obviously straight into S3. For that kind of real-time dashboard, that fits in quite nicely with Dynamo, where you can just push your metrics into Dynamo and obviously have them read very quickly by a dashboard. For the longer term analysis, Redshift's a good spot for that because you can obviously push that in there and then do your analysis there. And then for the more interesting stuff around machine learning or recommendations, etc., you might actually want to push that into something like Elastic MapReduce. So an interesting technology, and the interesting thing for me is talking to customers about how they're using it. And almost every industry has looked at it and seen some kind of applicability for what they do. Not least of which there is the gaming industry. So obviously one of the key things for gamers is to for gaming companies is to be able to see what's happening in the game. So how are users going? Are they getting bored? Do we need to incent them somehow? We've got some customers, for example, that will actually change the gameplay depending on how the user is going in the game. So if the user is getting frustrated because they can't get to the next level, they'll change the gameplay to keep them engaged. And so Kinesis is a great way to capture that information that's streaming out of the games and then actually do something useful with it. So one of those customers is Supercell, obviously the guys behind Clash of Clans, and their quote there was that it enables business critical analytics. So this isn't just a nice to have, this is critical to their business, and it allows them to get that information reliably. But as we talked about before, he mentions that it offloads a lot of the developer burden in building a real-time streaming platform, and it allows them to focus on delivering games that delights their consumers and their customers. And so again, it's all about removing that that burden of infrastructure that actually adds no value to your business at all. Let us do that, and obviously let you guys focus on what you do best. Just a quick plug for if you're interested in the big data technologies. If you go to the Amazon site /big data, there's heaps of information around some of the case studies we talked about today. There's some free tutorials there, lots of good articles, etc. Also, there is a free trial of Redshift on at the moment. So if you fire up a cluster of Redshift, you can run that for a couple of months for free, and so you can find some information on that at the URL. That's it from me. Thank you very much for being with us today. I hope that was useful. Please do fill out the survey, because obviously we'd love to get your feedback and work out what we do for future sessions. And hope to see you all again soon. Thanks very much.